It's not that I don't have any windows that are open. No, I've got like 5 million windows open. All right. Okay, so last class, if I remember correctly, um, we. Oh, before I just want to make sure I'm. Hold on, sorry. Okay, yeah. Just want to make sure I'm still recording so I can post it later for you guys. Okay. Um, Last class, I think we ended on passing pointers to a function, correct? Does that sound familiar? You can give me a thumbs up if you want. Be simple. Um, okay. Just making sure that was picking back up where I kind of left off. Okay, so we talked about passing pointers to a function, and I say there's some easy ways to do stuff, and there's some hard ways to do stuff, and I like the easy way, and so I instead of doing something like this, I say do something like this, which is you're just using references, and it becomes a lot simpler in how you have to do things. So I don't have to remember, am I using the ampersand, or am I using stars, or am I using, all these other possible things I could be using, but it's a little more complicated to keep track of. So we went with that. Now, the next logical thing for you to kind of make a jump on is okay, if I can pass a pointer to a function, can I return a pointer from a function? And the answer is yes. And it's very simple. Um, you just say your data type and then put the star after it. So, like, here's a generic function, you know, and I say int star, and it says, okay, this is a pointer data type of type integer, and so it will return an integer for you. Now, this isn't really useful for primitive data types. I'm just going to be flat out honest with you. I can't think of a single time where I've needed to write a function that returns a pointer to a primitive data type. Remember, your primitive data types can be things like your integers and doubles and floats and bools and stuff like that. Okay. Um, Technically, you can use this to return an array. Remember, you can't normally return an array, but an array name is a pointer to a location in memory, and then the index specifies how you index into that array based upon that pointer. Um, so that's kind of just what that is used for. We're going to find this to be a lot more beneficial is in a section that we're going to have coming up in just a few minutes, where we're going to create an object, and the object is going to be created inside of our function, and we want to return that object. Um, and there's a lot of reasons for doing that. For example, I might have a function that reads in a data file. And so I want to return an object that I read from my data source, whatever it is. That data source might be um, a database, it might be a flat file, like a text file or a comma separated file. Um, there's a lot of different ways I can do that. So that's where it's going to be really powerful. And stuff like this, I don't even really cover. I just say, hey, yeah, you can do it, but it's really not a big deal. Um, Even return an array is of minor use, and it depends upon how you do it. And the book takes, if you read through this chapter in the book, you'll see it takes about 2 or 3 little subsections for it to like build out how to reverse an array. And the first section they show you on how to do it, it's like I went through. I like, wait, I need to do this. Like this looks like it's gonna mess something up, and I was right. I actually did. Um, but then they go this way, okay, and then you see what this error is and why it goes through. So, um, and they talk about having to create an array using pointers and doing some other stuff like that. And it's a little bit cumbersome, is the nicest way of putting it. Um, so it's not my preferred methodology, but it is what it is. Um, So I try to keep things a little bit simpler than that. So we'll see that in a minute. The part that I'm going to talk about is specifically though is the how we're going to create and access dynamic objects. Um, and you might say, okay, well, what does that mean? What is a dynamic object? Well, typically when we've created an object so far, we would say something like circle and then specify, circle one and we pass the parameters to it. Um, it's very simple, works very easily. There's nothing wrong with that, but it has a couple limitations. So your memory space, and this is more for older applications. It's not as big a deal now with the new way that Windows has changed their memory mapping operations, especially. Um, but it used to be we had two separate sections of memory. We had our lower section, and uh, that's if you remember back in the old days of DOS, you might have heard people talk about DOS and how you might see something where um, Bill Gates makes a comment like, "I can't see why anyone would need more than 640K of RAM," which, by the way, he did not say. Um, that's one of those things that he's accused of saying that he didn't actually say. Um, those type things, that was like a lower set of memory, and the reason why was actually goes back to um, Intel's architecture on the chip. If you go on the chip design and how they separated out memory registers, they could only access the first 640K of RAM initially. Well, anything outside of that became um, either, and depending upon how you set up in DOS, either what they called extended or expanded memory. And you would think, well, aren't those synonymous? And they are in the English language, they weren't in computer terms. Nowadays, 640K is nothing. Um, we routinely, I won't buy a machine that has less than 8 gigabytes of RAM. Um, so forget megabytes, we're in the gigabytes of RAM. So what used to happen is we'd have the small little pieces of memory, and then we'd have a larger piece out here that was referred to as our heap. And so we would put a small pointer here to access a larger chunk out here. Um, Nowadays, like I said, with the way Windows does memory management, it's not nearly as big a deal. Um, I'm assuming it's similar with other OSs, um, but we still use some of these same um, kind of methodologies, for lack of a better term. When we create a dynamic object, we create a pointer, so small piece of memory here, to access a larger chunk of memory out here. Um, that becomes very, very powerful for us, because what that means is I don't have to have a contiguous space down here. I can find a contiguous space out here. And now we've got gigabytes of RAM. That's easier to find that chunk of memory. So the way we do it is pretty simple. We specify our object name and we give a star, just like we create any other pointer. We give it an object name, circle one, and we say equals, and now we have to use, though, a new keyword. And so we see the keyword new being used all the time. If you look at any application of any size at all, you're going to see new every time we're creating objects. And this is what we're doing is we're creating the object, we're specifying the class name so we can call the constructor, and we'll pass in parameters or not. Um, here's an example where we're not passing a parameter with new circle, the open close parentheses, or we can specify just new circle without the parentheses. We can do both. Now, personally, I always put the parentheses. If you remember correctly, um, from a few weeks ago, I made the mistake. I kept on trying to put parentheses with it, and that's just because it's just so ingrained inside my brain that this is how we always do it. Um, and the reason is very simple. It makes it look like a constructor. It makes it act like a constructor. I'm just really used to it. The part I forgot, my personal disconnect was, oh, that's right, we're not putting it into a pointer. You just get kind of in a habit. So if we come over here and take these real quick, let's see if I can copy and paste these into our application. Here's Visual Studio. Okay. So here I have circle 1, which is an object, and I specify new circle, and I give it a parameter. Here's circle 2 with an object. This is a no arch constructor. This also technically works. So if I say cout circle 1 circle 1. Now, because I'm using a pointer, and this is an important piece, because I'm using a pointer, um, one of the things that I can't do is I cannot use my dot operator. So if I say dot get radius, you'll notice that C++ says, whoa, wait a second. And this isn't C++, this is actually Visual Studio that fixed it for me. If I went in with like a text editor, it would let me type it. It'd just give me an error when I went to go compile it. Visual Studio goes, you can't use a dot because dots are for when you have a local object. Because you're using a pointer, we need an arrow reference. Okay, and so it uses a minus sign and a greater than sign to kind of create this little arrow. So we say circle 1. Well, what about circle 1? We need to get the radius. Well, how do we get the radius? We're going to use it using uh, this pointer. Because we're using a pointer, we create the arrow. Okay. So if I had a period in here, let me see if it'll let me put a period in here, if it's going to always fix it. Okay. So I was able to mainly kind of force it to do, okay, here's my period. Notice it gives me the error here. And if I kind of right click on, let's go to build so I can get the actual error message it'll give you. Okay. So left of get radius, if I look down here, left of get radius must have a class structure union, and it's a pointer, it's not a class. Okay, that's why it doesn't like it. We come back here like this and do build my solution. Boom, it works. Okay. There is another way. I can do parentheses star, we'll do circle 2 dot get radius. Okay. So here I'm using that star operator so I know, hey, I'm talking about the pointer. Now that I've got the pointer, I can kind of dereference this and get my radius this way. And this will also work. And if I look at these two things, you can see I have circle 1, which has the value I put in there for it. And I have circle 2, which has a different value, the default value. So they both work. Now the question is, they work the exact same way, but which is the one you think is going to be most commonly used? Well, you're probably going to say, well, I'm thinking maybe the first way because it's got a few less things for me to have to type. And if that's what you're thinking, you are absolutely correct. Um, there's fewer things to type. There's fewer things to hold down the shift key for. Um, that's not to say you won't ever see this second method here, but the first method where you use the arrow operator, that is very much preferred. Uh, it is used a lot more commonly. It's what I see when I look at other people's code. It's what I've always used when I've written C++ code, um, just for simplicity's sake. So do keep that in mind. It is a simplicity type of thing. It is designed to make your life a lot simpler and easier. Uh, so it is a good opportunity as far as that goes. Um, okay. You cannot, this is going to be my other last ones. So we'll do this one with circle 3. The big thing you don't want to do is you don't want to mix these up. So if I try to do star circle and then use the arrow, that's not going to work. If I say, well, maybe it needs the parentheses, is that going to make it work? The answer is no. It still gives an error message because it's not the right type. It's not a pointer. You're dereferencing it. So you want to make sure you pick one and stick with it. I highly recommend the arrow operator. Okay. Any questions on that? Okay. I'm going to assume no. I keep getting a little message saying that I've got a weak internet connection. It's probably my sons, they're all probably online right now trying to do their own schoolwork. Um, okay. Okay. So let's, um, when we are using the, the pointers and stuff like that, it's very easy. Um, and when we create an object, a lot of times we need a reference, okay, what variable are we referencing? And we need to specify we're looking for a property inside our existing object. To do that, a lot of times we'll use the this operator. It's a special keyword. It's a pointer that references to the object we're actually in. So if I have, for example, a constructor called radius, um, well, I've got a property called radius. So if I specify radius, which am I talking about? Am I talking about my local objects property, or am I talking about the parameter that just got passed in? And we want to keep things, so they make sense, and we gotta have good variable names in there, even in our parameters. So I don't want to call it R, especially if I have a lot of parameters. I'm trying to keep things straight. Um, in some functions, you can have a dozen parameters being passed to it. So you want to use good names. So a good methodology uses this keyword, and I can specify this in an arrow, and then the property I'm talking about, and that lets it know internally, like, hey, I'm talking about a property that belongs to this object, not a parameter. Because by default, it's always going to look at the parameter, not the um, property. Okay, so that's what the this keyword is about. I'm, I'm having some real technical issues. Give me just a minute. Let me see if I can get these resolved. Um, so I'm going to pause this for a couple minutes just while we try and get that solved. So it just it could be just that Comcast is being pathetic, which they are, especially out where I am. Yeah, I'm paying for 300 megabit connection speed, and I'm getting like 15. And if I call them out, they're like, "Oh well, you have an old modem. You need to buy a new modem." I'm like, "No, it's not that bad. It's not that old." All right, so we looked at this. Let's look at destructors. Destructors is kind of an interesting thing inside of C++, and other object-oriented languages too. And most object-oriented languages, your newer ones, your C sharps, your Javas, Python, stuff like that. Your destructor is handled for you automatically. In C++, because of the age and when it started and the resources and stuff that are available to it back then, it put more effort on the developer. And I know we've talked about this numerous times, and just kind of like a funny little anecdote that I saw. Um, there's been a lot of communication recently about the COBOL language because it's running a lot of the back end government applications. And some of these applications are like 30 and 40 years old. And that's causing a problem because COBOL is not something that is taught in modern university systems. Um, I can't think of anywhere where COBOL is taught. where you can go and take a COBOL class. You might go and find one that is on the records um, as an elective, and it's just not been offered for 15, 20 years, possibly. I don't even remember the ability for me to take COBOL when I was a student 20 years ago now. And so I happened to see a video real quick, like 100-second long, introduction to COBOL essentially. And so I said, let me take a look at this and see what it's like. Just what can they cram into 100 seconds? So they started talking about it. It's kind of interesting. Um, but one of the limitations is you cannot have any characters past column 72 in your source code. If you go more than 72 characters, you have to go to a new line. I thought that was kind of a weird rule. And okay, why is this, a weird rule? And so they go and they explain it. It happens to go back to when COBOL was originally written. You had to input it on punch cards. Um, if you guys are familiar with punch cards, is anyone familiar with punch cards, or have you never seen those before? Yourself, curiosity. Uh,
I've never seen them before except in like TV shows, but I know of them.
okay. If I mention punch cards, do you guys? Does anyone else know what I'm talking about? Um, let me see if I can find. So this is. Uh, that is not the punch card I'm looking for. Let's see here.
It almost looks like a Scantron.
Yeah, here's a punch card. That's the punch card. Um, and this you literally had to go and take like a hole punch and punch these special holes in them. Now you didn't actually use a hole punch; they had a special tool for doing it. But based upon um, what you put in the cards, you could. This is how you programmed your code, and you might have um, uh, I remember talking to a guy when I was about your guys' spot in college. I was a sophomore or something, and he says, "Oh yeah," he says we used to carry them around in shoe boxes. Because a program was measured not in lines of code, but how many punch cards you might have. 400, 500 punch cards for a big program, a senior project type thing, and that would take you like all semester long to create. Like, okay, you're going to create one program. This is what you're going to do, and okay, go ahead and start working on that, and that type of thing. And the professor like talk about other stuff going on, but your whole project, 400, 500 punch cards would take you a semester long to go out of punch because you had to punch them, make sure they all worked, um, debug your code and all that type of stuff. And a lot of times these were known as bash applications, so you would drop them off and you had a computer operator who would be working at the mainframe, and the mainframe would sit there and he would load them up and give you a written printout or whatever. Okay, this is what your program returned, or it had an error here, and then you would have to go through and try to figure out what it all was. um, the old punch cards used to have 72 columns if you went across. um, 72 columns. This one looks like it might be a little bit bigger, might be 80. Um, if I'm reading this right, from one on the bottom row, you kind of see one, and you see it goes down all the way to 80. The old ones in 1959, when they were created, only had 72 columns, and that's the reason why COBOL has a limit of you can only put 72 characters on a line of code. Not only that, the first like 8 or 10 columns are restricted for other uses. So you actually only have like 55 or so um, columns you can actually use for your code, and then you have to go to a new line and stuff. And it all goes back to a limitation from 1959 on these stupid things. Uh, And so when we talk about, sometimes we get limitations from old systems. Um, I've never used a punch card. I've never had to. Thank goodness. I don't think I'd have the patience to. Um, my ADD would just not let me focus enough to punch all that stuff out. Um, you guys clearly are never going to have to work with punch cards unless you develop time travel. Um, and that's not the era I'd want to go back to personally. So, um, as far as that type of thing goes, um, there's a lot of things I think you can look at and say, well, thank goodness it's not that bad, or we're not that bad, we're doing a lot better. Um, but sometimes when we see some of these weird things, like having to create our own destructors and manage that, it's literally because of old stuff like this that we're having to take care of. So, what is a destructor and how is that being used? In our case, one of the things that we're looking at is, once we've created an object with a new. Remember, we have our lower memory space down here. We create a pointer to an object out here. Well, what happens if I need to get rid of that object? I'm no longer needing it. Well, I should be able to call the. There's a special command out there called delete, and I can delete it. I can make it go away. If I create it inside of a function, when that function ends, it gets deleted. It goes away. The problem is, and this is because of efficiency's sake, if I have an object and it has a pointer to another object, okay, so we can have objects can contain primitive data types, they can contain other objects, they can contain a pointer to another object. When I delete this object because I got to the end of my function, this object out here that was created stays. Now, nothing points to it, but it's being consumed in memory. It's flagged by the operating system that this is being used and cannot be removed. And it's just sitting out here. And so the operating system says, well, let me give you a little bit more memory so you to make up for this. So when you get a certain amount filled, it says, well, here's another chunk of memory. Oh, here's another chunk of memory. And all of a sudden, your program, which should only take a couple of megabytes of space to run, is taking tens of megabytes of space. Or maybe it's only supposed to take a couple hundred megabytes of space, and now it's taking a gigabyte of space or more. Okay? This is what's known as a memory leak. And you've probably seen this or experienced this, where it's directly or indirectly, I don't know. But you've probably gone through where you've had, if you have an application that runs for a long time, it's just taking up more and more space, and it's going to eventually, you're going to run out of memory. Um, Now, the good news is, once your computer application closes, anything that was tied to it goes away. And so, if you had um, an application, let's say it was taking up, 6 gigabytes of RAM, because it had bad memory leaks and it's been running for 3 weeks, and the program then crashes, or maybe you hit the exit button. I don't know. Then what's going to happen is it's going to go and say, okay, here we go, and it goes away. That's fine. Because it went away, all that memory is able to be reclaimed, or at least most of it. Um, every once in a while, you get a few freaky things that don't get cleaned up. You have to reboot the whole system to do. But for the most part, that memory all gets cleaned up for you. The problem is, I don't want to have to rely upon my application crashing or someone exiting the application or anything like that. I want to keep good memory management best I can. So C++ has a destructor object, and a destructor object is smart enough to go in and say, anytime I'm going to get rid of a function, I'm going to call my destructor object. I can also implicitly destroy an object calling the delete command. So I have to specify as delete, and it will get rid of it. But if I don't, say I get to the end of a function, I create inside my function, I create an object, here's my object. I get rid of this object by calling the delete. The system essentially calls delete for me. It runs my destructor. This destructor should be smart enough to say, oh, I create an object right here. Let me delete that. And it removes it, and then it removes this object. Okay? That's a really, really easy way to handle my memory management. Now, that means anytime I create an object inside of my other object, I need to make sure that I delete that. That's a real important thing. If I don't, I'm going to have all types of issues. So just kind of keep it in mind. Um, it's real easy to forget one. Oh, I created this object, and oops, I forgot to create the destructor or call the delete function for it. Um, my general rule of thumb is anytime I create a pointer property inside of an object, I'll then go to my delete or my destructor object and say, okay, if it's not null, delete it. Um, and that's just to make sure I don't forget something. But it's hard to do. As your programs get more and more complex, it's easy to forget to do something. So that's always an important thing to remember. Um, my web browsers, if I bring this up, and I just recently rebooted them, so they're only around a gigabyte in memory. I rebooted them because they were around like 3 gigabytes in memory, how much it was taken up space wise. Um, just as it's remembering all of those cache files, as it's remembering what is previously done, and all types of stuff, it gets really, really big. Um, so to create a destructor in your source code, remember you get a default one that just deletes all the primitive data. But if you want to get the other stuff, all you have to do is you specify, this is assuming you're using a header file, which for a big object like this, you're going to want to, for sure. So you got circle, colon, colon, and then it's so you have whatever class name it is, colon, colon, a tilde, and then your class name again. So it looks very similar to a constructor, but it's got that really big difference in it. It's got that tilde in front of it. You're going to notice it does not have a return type, and you shouldn't need to pass any parameters. I can't think of a single instance where I've ever had to pass a parameter to a destructor. Now, the example that the book was using, and I've been following along with the circles, remember whenever they called a constructor, they added one item to it. So this is going to get rid of an item. So that makes that helpful. Keep an active amount. And then let's say that we had an object that we call location that defined the X and Y coordinate for our circle. If we're trying to graph it out, um, we've got where we see here delete and then that object name. Okay, so it's very straightforward, very simple on how it's going to run. You don't have to worry about that. All you have to do is say delete and then your object name, and you're done. And you do that for all your objects. Now, like I said, as your objects grow in complexity, this becomes something that's easier and easier to forget. So we have to be very mindful of this. But if you are, you're going to save yourself a lot of headaches over time. Um, the biggest issue you're going to run into, and something you have to keep in mind, is when we start looking at the next section, which is a copy constructor, and what happens if that object is shared between two objects. Um, So you might have been asking, why do I care about a number and count of how many items are being used and stuff like that? Um, one of the reasons why, and one thing to be careful of, is if we have two objects out here and they both have pointers referencing a same third object. So if I delete this object, but this object still exists and it's pointing to the same smaller object over here, I don't want to delete this object because then this object can't reference it. And that becomes the other big problem with using your destructors is you got to remember, okay, am I creating objects that are referencing objects that other objects are referencing? Okay, now you start to see where it gets a little complex. Because if I delete this object and this one out here still needs to be able to access it, but it's gone, now this can crash, and that creates a real problem. Okay, so I've got to be kind of careful with my destructors for how that's going to work. Okay, let's look at the copy constructors. I just mentioned that and say, well, what is this copy constructor? You've never mentioned it before, except this little reference. Let's talk about it. Okay, so we've talked about a constructor. We know what a constructor is. We know what it does. Um, in C++, there is also a special type of method called a copy constructor. So we have three main methods that are every object has. Um, you get a default version of this that may not be what you want, but you have a constructor, you have a destructor, and then you have a copy constructor. And a copy constructor is a special type of constructor that is used whenever you want to duplicate an object. Now, sometimes this is referred to as cloning. So I have object A and I need to have another object that looks just like it, object B. So I could go in and pass in all these properties and stuff like that to it. It's a challenge, but it could work. Um, the other option is to create in to just say, hey, I'm going to create a new object and I'm passing in an object and I want to duplicate this. So it's an object that accepts an object as its parameter so I can duplicate it. Now, when I do this, I actually have two different ways I can copy the data. The two ways are known as shallow copy and a deep copy. Um, and you'll hear me talk about this in other classes too when we talk about algorithms and we talk about data structures and we talk about all this stuff. Shallow and deep copy are actually very important to us because of what they do. Now, they do one thing the same, and that is if you have primitive data. So things like your booleans, your integers, your doubles, your characters, floats, all that type of stuff, your primitive data types, it makes a copy of that. So it says, okay, I got four here, I can make four here, and they are separate, they have equal values. If I change this value here, this one stays the same. So if I have four, I duplicate it, I clone it, I have four over here, I say, oh, five, this one still says four. It's like a snapshot. Okay. Now I can come over here, likewise say, oh, update this to 7. This one's still 4. They're not connected. Now a shallow copy is going to say, well, if I have a large data type or if I have a complex data type, so I have, remember, an object that has objects in it, or maybe an array. I can say, well, copying that data might be really, really complicated. It might take a long time to do because it's a lot of data. It's going to take a lot more memory space. So I'll create a shallow copy. So I have an object here, and let's say it has an array of this. Let's say this is like a course class, and I need to keep track of all my students inside the course. And I have an array that lists all of my students. Okay, that makes sense. I copy this. I do a shallow copy. A shallow copy says, well, copying an array with all those individual students is going to take a long time. I don't want to do that. So therefore, I'm going to say, this is a pointer to this array. I'm going to tell you what the memory address is, and we're both going to reference that same array. Remember what I just mentioned about the destructor? I got to be careful about two objects referencing the same third object. This is a perfect example of that. A shallow copy where I have two objects pointing to the same data type, same memory space. Okay. Now you say, well, why not just duplicate that values? Well, if I've got a class like ours and we've got a half dozen people in it, it's not really difficult to copy 6 people. If I've got a huge lecture class, like in UCF, I had lecture classes that had 400 or 500 students in it. That becomes a lot more complicated. copying that much data. Not only does it take time to copy all those data, all those individual pieces, it takes up a lot more memory. So a shallow copy is going to be used when I want to save time and space and memory and things like that. If I want to have a deep copy, that's when I go and take that array and say, okay, let me create a new array. Okay, element one goes into element one. Element two goes into element two. Element three goes into element three. And I'm going in and I'm duplicating each of those values. I got to use like a big for loop. I got to create the array. I use a for loop and step through all my items. That's my deep copy. Like I said, if you get just a couple elements, it's like a 6 element array. It's not that big a deal. 10,000 elements, bigger deal. So I got to go through that process, and I've got to go through that process to go through that process because I don't want to have a deep copy of mine, but then let's say I'm dealing with a student, and because I got a course, I have a student, and a student, I'm gonna have all their information, which includes, let's say, an address. And now these two students that are now duplicated, do I want to do a shallow copy of the student so it points to the same address? Or do I want to do a deep copy? And that's an interesting question because as I get deeper and deeper and have objects within objects within objects, I'm going to naturally be calling these own copy constructors. If I do shallow copies some places and deep copies other places, I can really foul up my data management and how I'm keeping track of stuff. So I got to really think about this as I get more and more complex. Um, Now, the good news is with some of the higher level languages, if you take things like data structures with me, or if you take algorithms, we're talking about other um, programming languages, a lot of this is hidden from you and it's managed for you. You don't have to worry about it. But in C++, this is something we have to actively think about. It's part of the reason why a C++ developer writes faster code because they can figure out the optimizations that work for them. They're not relying on some generic thing over here that the other system's going to manage for them. It's going to be good for everyone. We can be good for us and what we're specifically looking for. At the same time, we have to be paid more because not only are we writing code that's faster and better, we have to write code that is better because we can't rely on someone else doing it for us. So a little bit of heartache on our part means a faster application in the end run, or a better, more stable application depending upon what you're looking at. But we're having to do more work, and so we're having to be careful of that. And so that's the reason why a lot of times C++ developers do get paid more than some of the other types of developers. Is there's some heartache that's involved, and we have to figure out how we're going to do it. Um, so that's kind of difference between your shallow copy or deep copy. Shallow is we're going to duplicate our pointers and say, okay, we're going to point to the same memory space. Deep copy is we're going to duplicate everything, and hopefully I'm going to be properly duplicating everything when I create my clone. So I got to kind of keep that running back in my mind. Um, so I did give a quick little note. I thought this was funny historical. This is from when I myself was learning how to code C++ years ago. Um, One of the things you could not do, and this was frustrating, is you couldn't go in and create an object with your constructor, your copy constructor, your destructor. You had to go in and create your object and not have your copy constructor, because your copy constructor, when you pass it, you kind of see the source code here. I say here's a constant with a dereferencing of your circle object to a template, so it can copy the data over. One of the things we'd have to do in that is it would say, oh, wait a second, I don't know what data type circle is. I'm creating a circle, I don't know what it is yet. And so you have to go and create and compile your code, and then you would have to have your copy constructor commented out. And then once you get your code compiled the first time and it created those objects, remember we talked about how you get an object and then you can link to it. Okay. Once it created the first set of objects, then you can go in and recompile your code and you go, okay, I know what this data type is. I see an object for it, so I can compile it, so I can create the object, so I can then go and link it. It was weird. Yes, I know, but it was what we had to do. Um, so I haven't seen that in more modern versions of the compilers, luckily, knock on wood. Um, that was kind of crazy. Your copy constructor, you can see right there in the example, it looks very similar to your constructor. The difference is one of your parameter or your parameter, the one parameter that you're getting, is the existing, excuse me, is your existing circle object. So that is your big difference there. Um, Also note that one of the big things I'm doing is I'm putting const before it. Remember, if I want to make sure that when I'm passing a parameter or something like that, and I don't want to change that initial value, I can put const. A perfect example is when I used arrays. Um, I can use that const keyword to ensure that I don't change my original. And so that's kind of a key thing I can look at there. Okay. Any questions on the copy constructor? To really see them in work, you've got to have like really, really complex objects and stuff like that. We don't at this point. So, okay. Um, good, good. Happy. All right. Last little thing. Let's close up punch cards. You guys don't need to see that scary stuff. Um, we'll do this, and then you'll be done for the week as far as this goes. I have got to one question already. Hopefully, I answered it for them. Um, we do have a homework that I've created. It is not due until next week. It's taking that circle class that we've created in class and through examples and stuff in the assignment. It's adding an x and y coordinate for two more properties. Two more properties. I gotta look and see where I am on the screen. Um, so I've tried to put in what you're going to need. You're going to need your constructors. There's like three constructors you're going to need for overloading. Getters and setters, get area collision detection, um, which is just going to return a true false type value. Uh, from that, the basic way of doing collision detection is you'll probably need to have a get distance method, and you'll need to see, okay, what's my distance between these two objects, and then from there, uh, how do I know if those two are connected? Um, and this is actually the basics for those of you who are interested in games. A lot of times, what a game will do, at least the older games would do, is they would go in and say, I'm going to create a sphere around this object. I know that my object is so big, and I'm going to create this invisible sphere. And anytime sphere from this object intersects sphere from this object, then I'll do a more detailed analysis to determine if the objects collided or not. And depending upon what this object was, if this was like generic bad guy number three, if you swung a stick and there was a chance that there might be an intersection, this guy might take a hit just for simplicity's sake, because we didn't have enough processing power or enough memory or anything like that. So this is actually the starting of collision detection, and collision detection is used in all types of things for graphics and virtual reality and augmented reality and stuff like that. If I can take a really generic one, then I might break it down into smaller sections and say, okay, did I actually intersect with the object? If this is a hero object, or if I got enough processing power and stuff like that, I might think, oh, okay, I need to make sure I'm actually connecting and stuff like that. And so this is kind of the start of it in a two-dimensional space. Um, we'll look at three-dimensional a little bit, and it's actually very, very simple to go from 2D to 3D for something like this. So, but spherical, because of how simple it is, and you can do some really simple math to make it work. Um, this was like the first thing that they would do, and they just simply do it just to make sure that uh, the you wouldn't have to do complex collision detection. Because collision detection can get, especially like a real time 3D game, that can get really complicated really, really fast. That's the nicest way of putting it. So doing something like this is a really simple way of checking um, to see if it needs to go further. All right, so I've given things broken down. If you do have questions on that, I do have office hours tomorrow. Feel free to stop by and say, hey, I've got questions, I have comments, I have whatever. You can do that. Um, this, however, because of the amount of work that we've already done in this, and you've seen this over the last couple of weeks, and there's notes and stuff on this, most of this should be pretty straightforward. Um, the checking for collision detection, checking for distance, those might be a little bit different. Um, so feel free to stop by office hours. I got them tomorrow. And just as a reminder, if you're under the general section, you can see the links to the virtual office hours. So um, if you do in the morning, and this is also always based off of Eastern time where the school's located. If you're doing the morning, you can do morning there. If you're in the afternoon, feel free to do the afternoon. Those work. Okay. Any questions on things we covered today? If not, thank you all for coming. I appreciate it. I will see you all in uh, next Monday. Have a good and safe weekend. If you have questions, stick around. I'll be happy to answer a couple of those for you.
Hi, I have a question.
Okay.